In this example, I'll show a typical workflow for designing machined parts. You typically start designing machined parts with basic features, like extrudes or revolves, that create, and then remove material, followed by chamfers and holes that mimic machining operations. Start by establishing key datums. The first datum comes from the modeling template, and the second datum defines the tip location and angle of the jaw. Next, I sketch the main features. Most of the design intent for this part is defined by dimensions and constraints in 3 related sketches. This sketch defines the outline of the jaw. I create this sketch first because it defines the function of the part. My second sketch defines the revolved shape of the part, and is relative to the jaw sketch. And my third sketch defines the flats on the shaft. Our next step is to create the basic shapes by extruding the sketches as if we were machining the part. I revolve this profile sketch to create the basic shape. Revolve the jaw sketch using the Boolean subtract option to create a hole for the jaw. Create an extrude feature to cut the flats on both sides of the shaft. Create a circular pattern to add the other 2 holes for the jaws. Add chamfers and edge blends, just as you would machine the part. The last step in this part is to create the internal thread. I'm using a detailed thread here for visualization. In most cases, it is a better practice to use a symbolic thread to create a less detailed model. To summarize, you typically design machined parts in 4 steps. First, establish key datums. Second, sketch basic shapes. Third, extrude or revolve those basic shapes to add and subtract material. And finally, add detailed features.